Hello, everyone. Welcome to another Common Lisp study group. I'm your host, Ram Vedam with Lent Functional Programming. I hope all of you had a very nice Happy New Year's and a holiday season with your families. Today, we're going to be continuing our discussion on kind of the final three pieces of the UIOP library. In most of these, if not all of them, deal with building executables and actually running applications in a portable fashion. Just give me 1 second here. I was trying to set something. This is okay. So last time we kind of covered the majority of the UIOP library. We covered kind of the third piece of UIOP, specifically up to configuring your applications, setting them up so that your applications are, for better or for worse, in kind of a systematic, a Unix style, or even operating system independent style, like application directory structure. And we talked about also how to run applications outside of the shell. We kind of went through quite a few different libraries last time, specifically in the realms of dealing with the file system, running different applications from the shell, running using UIF configuration to actually read and write configuration. Although I still, like I mentioned last time, I could not specifically come up a very specific example of looking at this. And the API, for me at least, there's a couple of things in there that I'm not entirely sure where we write specific configuration. I'm still working myself through that specific API, the configuration API. There's a couple of things in there related to not just grabbing configuration, but you can also modify existing configuration too as well. But that's stuff that I'm going to leave to another episode, just mainly because of the fact that between the holidays and now, I was unable to actually come up with a really decent one that would pick up like an existing configuration and actually just validate it for you guys all. From what I can tell, at least, just to give you guys a quick update, and then we can move on from configuration specifically, was it is using standard conf ini style configuration that's pretty typical of a lot of Unix configuration files. They're not ini specifically. Ini is kind of the Windows term, but they're key value pairs essentially. So you'll end up reading this configuration into a map essentially of some sort and be able to validate that the configuration matches what your application may or may not need. If you're reading a system configuration directory or a file from a system configuration directory, that will generate just a map of read-only members that you could go and retrieve specific pieces of it for your own application needs. Again, I won't touch too much beyond that, just mainly because, like I said, there's a couple things that I myself am not entirely familiar with, that when I went through this the first time around, I thought I understood it, and it turned out that I was kind of wrong. So I was like, rather than bumbling around on configuration for this episode alone, I would just going to defer it to another future one, so that way we can move on to our final three libraries, packages inside the UIOP system. So up until now, we actually covered a good portion of what UIOP actually provides, and I hope through my discussion and presentation, you're getting a sense that really, if you want to write portable common Lisp code that works well and integrates itself quite well into ASDF and the ASDF ecosystem, UIOP is a good way to go. Especially since Quick Lisp and a lot of the package managers kind of adopted um, ASD as kind of the base. I'm pretty confident that if you end up using UIOP and if we end up switching from ASDF to something else, your code will actually also work without too much trouble, as long as you provide UIOP as a dependency in your project. We've talked about all the packages, just a quick review, the package API, how you could define packages for hot reloading and so forth, some of the gaps that are filled in by UIOP through UIOP/Common Lisp, some utilities that are provided for dealing with different types of control flow, plist, control strings, other primitive types, classes, conditions, and so forth. A lot of these that are not dealing with I/O are, falling under the UIOP/utility library. We've dealt with OS-specific things, which is, how to get environment variables from your operating system, how to grab the host names, current directory, how to change directory inside your application image, and so forth through UIOP/OS. We talked about also path names and the file system API last time as well, and we covered the stream, the nice portable stream API that they provided for dealing with OS-specific streams such as standard in, standard out, standard error, and being able to read-write things from these streams in a safe manner, as well as being able to open temporary files, output buffers, and so forth. So what's left inside UIOP? This is such a big library that's kind of around us, that's already built in, and what else can there be inside this library that would be of use to us? Well, obviously, once you've gotten to a certain point and you want to dump your Lisp image, so forth, to create an executable for other folks to use, you will end up falling into the trap of wondering, well, how does my Lisp actually go in and build and actually set up a Lisp executable for distribution? We've talked a little bit about this in this stream in the past with dumping images inside SBCL, or using Roswell to actually create what I normally do, which is write a build script that will set things up to do essentially Lisp, save Lisp and die, which is a typical way in SBCL to go and generate your native executable with the main entry point. And I defer to those kind of earlier episodes if you want some more information regarding those things. But UIOP, in addition, provides a couple of things related to building and compiling Lisp code on top of the existing Lisp implementations themselves, and again, a cross-Lisp manner. It supports multiple Lisps. I encourage you to go and look at the UIOP documentation to see where the gaps fill and where they don't necessarily fit or are completely incompatible with existing Lisps. But the specific libraries that we're going to be touching base are two libraries. And these are two sub packages inside of the standard UIOP system. The first one is UIOP/Lisp build. This library is a library that deals with compiling Lisp code specifically first. It also handles compilation results. If you want to suppress certain uninteresting conditions over the course of actually compilation that may or may not occur, you can certainly do so through this library. Other things it supports also deals with things like saving and restoring deferred warnings, hooks, providing compilation hooks, so you can, for example, control certain types of compiler optimizations to your Lisp code and so forth. Being able to merge and load Facile files, identifying, path names of the current file that's being compiled and so forth. The fairly simple library with dealing with compilation, but you could think of this like sort of the equivalent of running compile or the compile as expression form inside your Lisp image. So for folks who aren't familiar, you have compile and compile file. I think both of these are part of the standard. If I'm not mistaken, it is part of the standard. I know compile is part of the standard, which obviously compiles a specific function for you, as well as compile file, which is, obviously going to be dealing with this at the file. I'll load the file into your Lisp image and then compile it for native code. So both of these, as far as I know, are part of the standard Common Lisp. And both will, well, in the first case, compile will compile a single function into native code, create a compiled function object inside your Lisp image, and every future reference to the function itself will end up calling the compiled version and not the interpreted version. SBCL, for folks who are aware of this, I'm sure the new folks who are unaware may have encountered this and wondered what this happens. SBCL defaults to compiling all of its function definitions. You have to explicitly turn it off in order for you to get SBCL to run Common Lisp in interpreted mode, at least as far as I remember. I haven't actually messed with the flags in a while with actually getting SBCL into interpreted mode, just because I kind of want my code to run as fast as possible. So what does UIOP / Lisp build build on top of this? Well, it has a couple of things. One is dealing with compiling with particular optimization settings and so forth. You have the ability, and I'll just go ahead and do this here in my Lisp buffer. You have the ability to say get optimization settings, which if you go and run in your REPL, looks like it'll end up telling you what the default settings is in compiling your particular Common Lisp function definitions. Of course, folks may have seen this before. If you've ever done declare optimization inside your function definitions, this is typically the same compilation flags that you would end up attaching to your function definition in that declare form, and then deal with each of the individual flags itself, specifically based on the use case. Debug obviously will end up providing certain debug instrumentation that would help the debugger to actually go and allow you to step through specific lines of code and so forth. Speed and safety. We've talked about speed and safety in the past when we dealt with profiling, and knowing the differences between actually using one versus the other. Two flags here that I didn't notice until I ran get optimization settings that existed, and I'm not entirely sure if these flags are standard. I haven't actually had a chance to actually go and look at, say, the Common Lisp hyperspec about this, but the two that I'm thinking of is obviously the two I didn't mention before, which is space and compilation speed. Different Common Lisp compilers may end up using these two in order for you to, like, again, in the case of compilation speed, actually determine how many optimization runs you end up doing, how many passes you build in order for you to get the final Facile, or in some cases native code executable that you want to actually go and run. I'm again not entirely familiar with compilation speed exactly, or space, just because I've never had opportunity or reason to actually use them. Usually, compiling, at least when you're using Steelbank Common Lisp, is fairly fast. And again, since everything is by default compiled inside that SBCL, I usually just look at the assembly by doing disassemble and see if there's anything that I could do at a higher level to actually go and optimize the actual final result of the code, regardless of what the actual speed is to get the final result. Space is something that, again, that I've never. I'm only going to briefly mention here. If you guys give me just 1 second, maybe the hyperspec would give us something about this. I don't believe I've seen this flag before, but we will see. Let's see if the hyperspec can give me this appendix. Here we go. Oh, so it does look like if you go to optimize, space and compilation speed are both part of the standard hyperspec. Compilation speed is pretty straightforward. What is space? The space flag actually deals with code size and runtime space, so the actual number of instructions to actually generate the executable to load it into memory. Some combinations of these, I'm going to say, at least from what I've been told, I can't really say that I've directly experienced this, will give you differing results, the results that you may or may not think you may or may not expect. All right, so I would say that for folks who end up using get optimization settings, or with the next thing that I'm going to show you with optimization settings when you're compiling your code, there is sometimes a cost of combining certain flags a particular way, and it depends on which compiler or how certain flag combinations may behave with each other. That's about as far as I can tell you about optimization itself specifically. I encourage you to play around with it with your Lisp implementation of choice, just because whatever I tell you may or may not fit specifically to your specific Lisp implementation. And I'd rather not provide you with false information. So let's go to the next thing here, which is obviously, which leads us to obviously the next thing, which is Lisp build with optimization settings. With optimization settings, obviously, is a macro that if we expand too few elements, let me see if I can get the safety to debug one. Let's see if too many. Oh god, did I mess this up? There is a. Let me go to. I thought I got the signature right. Just 1 second. Okay, so we gotta go back to, and you could first, So the first thing I'm doing is I'm getting the current optimization settings. Oops, sorry, this is a global, not a function call. There we go. Okay. Let's see here. Maybe we can do this. There we go. That's what I had to do. So, looks like in order for you to use optimization settings, you need to provide a list of the optimization settings that you want. And this makes sense because, again, as we saw with this code here, it ended up taking a list itself. So I went ahead and make a dummy list. Let's say that we're compiling a dumb function, like say add two numbers, and obviously I know I'm going to say that these two are fixed sums. I think I have to do fixed num A. Fixed num B. And then we do AB. So if we compile this guy, this is going to go ahead and compile it with those optimization flags. When we expand this, you can see that what this is doing is essentially it's injecting that declare proclamation that I was telling you about that you would normally do when you're compiling specific pieces of code. Now, obviously, this doesn't really help. I think sometimes a lot of folks end up actually writing it this way. Although I think this might work. I think it's normally, if I remember correctly. So you could write it at the function declaration level, which is what most people would be familiar with, which is what we did here. But you could also do the following, which is put it at a lower level and not deal with the function declaration itself. So to do that, it'll look like something like this. And obviously the code will be effectively the same thing. If you maximize, not this, sorry, this guy, you'll see that it essentially did the same optimizing at the function scope level, and you haven't actually changed much. Both ways are a little different. I think it's a stylistic thing, and I've seen it actually used in both situations like this. And I haven't actually seen what to be honest, a clear best practice on how to use some of these proclamations and declares to actually for code optimization. Folks who are familiar with some best practices, please let me know, and I will go ahead and post them here. So now, again, I'm not gonna cover everything. There's a couple of things that I just wanted to highlight about this particular things. Some of the standard things that we were doing before regarding compilation, like compile, like what we were using earlier. You are the equivalent of these inside UIOP/Lisp build is compile file. Compile file actually takes, I think, multiple arguments here. One is you could specify some specific input file, some additional keys, like whether or not you should be checking, running a compile check, which is like a type check, and amongst other things. What the output file should be. Should you emit C in the see Facile or not, or which is I think specific to certain Lisp distributions where you can emit C, and where do you want to dump your warnings so you don't necessarily see the warnings inside your Lisp image. You might want to save them so that you could go back and take a look at them later on, just in case that there are warnings that you may want to fix. There's also compile file with the path name. This guy is just merely going to be nothing more than the same thing as we did before, but it's going to take an absolute path instead of a relative one, which is what if I recall, what compile file does. Compile file star does. Again, a lot of these you can take a look at by simply doing documentation, running the UIOP/Lisp build. Almost all of these have doc strings, so it fits quite well into doing interactive development. So you can look up things, run apropos, and actually find what your specific file functions that you're looking for, and so forth. So in this case, you can see that this is just compile file path name that is part of standard Common Lisp, but it gives you the equivalent of that for UIOP Lisp build. And bottom line is a lot of the stuff that the Lisp build API provides in UIOP are equivalents to or variants or wrappers around some existing functionality that's already available in standard Common Lisp, but they give you some extra things. So, like for example, the differences between compile file path name and compile file path name star is literally just that compile file path name star works well with compile file star, whereas compile file path name in standard Common Lisp works well with compile file. So you can mix and match some of these things when you're doing this. You can literally, I think, do a 1-to-1, convert your standard Common Lisp calls to any of the compile API calls to the compile star calls that are available in Lisp build. Any questions about this? Okay. Let's see how this might work. So if we end up doing this, compile file path name, let's see what happens if I do this. This is some hope unavailable, possibly. Let's see if I have a test.lisp somewhere. Yes, I do. And let's do that. So you'll see what the generated compile file path name here is. If you do UIOP/Lisp build star, you get a proper path name object here that gives you everything that you wanted, and this is what's needed for compile file star. Compile file star is dealing with proper path name objects. Obviously, I can show this to you, but I don't think this is necessary. This is, as you can see here, this is not going to work well because I provided a string. If I do #p, it's going to also not work because, again, this is the reader macro equivalent doesn't necessarily work. But if I do this, sorry, the REPL. If I do this, which returns this, and I compile using UIOP Lisp build. Home is not allowed as a directory component. What? That does not make sense. Let's see here. Okay, let me see if I give instead of using standard, I gave an absolute path. What would happen? Users, freedom, software projects. Failed to find the true name of a file directory. Okay. Oh, this is dealing with. This is not a problem with my call to it. This is a problem with how it's a problem with the destination. Let's do this. It's an issue with how I am leveraging how Mac is using is redirecting to the local cache for Quick Lisp to actually go and write to this location, because as you can see here in the case of this example, typically when you're compiling stuff, at least if you don't provide a default location to where your facils are going to go, which in this case I did not provide any sort of like specific location of where my facil should go, and this is provided by the use of the output file location. Key word here, as you can see, and I'm not sure if most of you can actually see my my MIDI buffer down there that's giving me the function signature, but compile file name file path name star allows you with the key value pair provide a destination of where your facil should go, and like what file should it be named as. And if you provided that, it will go in and go ahead and compile it into that location. But in this case, I was trying to use the default location, which is in if you don't provide anything, it's in .cache/common Lisp. It's not even in quick Lisp /.cache or what anything like that. So it ends up throwing it into this location, and since the file doesn't actually exist there, and the path doesn't actually exist there, it's throwing up an error. I can probably fix this by doing a let's see, SPCL 204 because I'm on the latest. Okay, let's see if I can do this. I'm going to go ahead and compile the file. This project's test.facile, because I'm okay with actually throwing this in for example's sake. So this is what's used. If I end up doing that here, do that, oh, oops, that UIOP / let's build compile file path name. Sorry, not path name. Compile file. Failed to find the true name of no such file or directory. Well, of course, you need to create it. Let me see something here. There might be a flag here that I'm missing that I need to turn on. No. Let me do that. Instead of using compile file path name, I will provide just the actual file itself, which you should be able to do like we did before, but for some reason it didn't work earlier. So let's see if why this is causing an issue. Output file, path software project. That's projects test.facile. Let's see what happens. That worked, as we can see here, because of the fact that we're dumping some stuff and we'll generate this Facile file. I think there's some some arguments here. I have to go and do some further testing, but there might be an issue between compile file path name and compile file that may not have been checked by their existing test suite, and if so, I just found a bug. But we'll go through that later. What else did I want to go through this? Well, there are a couple things related to warnings and deferring warnings and dumping warnings that I don't necessarily think we need to go through here. I encourage you guys to go look at some of them. These are mainly dealing with, again, it's going to be dependent upon the Lisp implementation of your choice. But it is going to be dealing with whether or not warnings could be errors. Can you combine them all into a single deferred warning? Can you actually make them all individual warnings so you can handle them one at a time? Can you dump them to a file? How do you load them up and then do another run check? There's a lot of these things. A couple of them that I will mention is Reify deferred warnings, unreify deferred warnings, reset deferred warnings, save deferred warnings, check deferred warnings. There's a lot of them here that I don't think I'm going to, just iterate what's in the API documentation. I'll encourage you guys to go and take a look at that and explore yourselves on this. The final piece that I was going to go and touch base with is a couple of global def parameters that are around that you would want to take a look at that are already built in. These are settings that you could set at a global system Lisp image level when you're dealing with this. One of them we've already seen, which is UIOP / Lisp build : optimization settings. By default, when your Lisp image is loaded with ASDF, your optimization settings, global optimization settings, are going to be obviously nil. I didn't set anything here when I loaded up this project. What I showed you earlier in line 90 on main.lisp, and for folks who want this code, I will go ahead and post this onto AFP's main repository after we're done with this. The settings that are available here in line 90, if you want this applied to everything, you could actually go ahead and just set up star optimization settings star, and then every function, if you put in with optimization settings and then put, I think, empty brackets, it will just default to whatever is available, which here, as you can see, is going to be empty. And if we, for example, set this by doing a let UIOP/Lisp build optimization settings be safety 2, debug 1. And we go ahead and compile this. This should be fine. If we go and maximize this here, you'll see that this is going to be set up to the global policy, and the global policy is set up to Lisp build optimization settings, which itself is going to be the same as the global optimization settings that you provided. Because if you actually go and look into the code, just for full disclosure, in the code of UIOP/Lisp build, internally settings, the default value of settings, if you look at the signature here, that optional is actually defaulted to the global variable, the def parameter. So it'll end up falling through in that particular case, although it may not show up here in the macro expansion. So that's optimization settings. There's additionally UIOP/Lisp build star compile checks for actually running different compile checks inside your compilation process. The other one that I want to show you is compile file warnings, which will give you what level are you treating warnings. For example, there is also compile file, what is it? The failure behavior, like what's going to actually happen if there are compiler errors. You could change some of these through the process if you don't want to, for example, go into the debugger and then run different conditions. You can certainly change that to being warned to as well, so that compilation process can continue, although I wouldn't encourage you to do that. There's also the default directory, which is what we were kind of looking at earlier, which is, where do you want all your Lisp file faciles to go to? Or if you're creating your final executable, where is that is going to go to? There's also translation functions for the output and so forth that you can certainly use. You can also, you have a couple of like checks APIs, like checking compile results or checking compile warnings. One of them I'm just going to show is that I've been looking into, but I haven't had a chance to come up with something that would be interesting, is this guy, which is it will take the results of compile file, verify them in some way, and then as the doc string indicates, it will either raise a error or throw a warning, depending upon the flag set for what we were looking at earlier, which is compile file failure behavior and compile file warnings behavior, respectively. We look at this specific and dig into this a little bit more. It's really checklist compile file results. Thank you. It's really taking a Facile file, two predicates on how you want to go and verify the Facile file, and then the format of the actual underlying context and its arguments, and it will go through and verify the actual compile time results based on those optional predicates, and then throw an error warning accordingly. What's the other one? Should I even? I'll just briefly mention this. I said this before about Lisp build. Lisp build provides you some way of dealing with what you may consider uninteresting conditions and uninteresting compiler conditions. You could tell them what to do with them. There's certain def parameters, some global variables here that you could certainly use. I don't like using the term global variables when we're talking about def parameters because, as I've mentioned before in past episodes regarding earmuffed variables inside Lisp, although they are treated as global variables in a lot of it has a close analogy with a lot of modern programming languages. They're more kind of like shell variables that are set up globally that you could, in certain let forms, as you saw what I was doing before in line 90, indicate differently based on particular conditions and scope them down to a specific section. And in that sense, their settings are isolated to that specific section, and normally these same def parameter variables are used for, and we've talked about this in the past, to do thread local storage and actually do concurrent programming inside Common Lisp, and be able to share data between different threads inside of a Lisp image. So they're not necessarily global variables, but I tried to use the term interchangeably just because usually you do not want to use these types of variables unless you are doing things like in the concurrent sense, or there's a specific case where you want to be able to manipulate different parts of your sequential code, and you don't necessarily want to have a lot of let forms being able to switch around. You want to use a common name for the same setting. But to go back to our discussion before, there are 3 or 4 different uninteresting kind of like flags that you could check. And I'm going to just briefly mention them here. And those are uninteresting. What is it? Sorry. Star uninteresting. And these are uninteresting conditions, loader conditions. Usual uninteresting conditions is also one that should be brought up here. And these are things that, your Lisp implementation of choice will be throwing up for when you're building something. So as you can see here, we're saying that things to ignore when you're dumping out stuff to standard out that are uninteresting to me are like simple compiler notes, lexical environments being too complex, undefined alien style warnings, and things like this. If you look at what's predefined for uninteresting conditions, it's usually, and again, for folks who are watching this who are using, say, not SBCL, CCL, or any other, or CLASP or anything else, your flag list may vary. So don't take this as some sort of like, source of truth. It's not necessarily a source of truth. It's dependent upon your Lisp implementation. So we now have the ability to, with this API in Lisp, set up flags and create extensions to ASD, essentially to be our build files, our make files to actually generate our code. We could write scripts in pure Lisp to actually use this API to compile our code in particular ways. But how do we actually deal with them? So, as most of you know, when you're compiling Lisp code, you have 2 formats. One is obviously an executable format that can be used to run your Lisp application. Normally what this does is if you do like save Lisp and die with an entry point parameter, it will actually generate the assembly code necessary to actually load the Lisp runtime prior to actually going and executing your main code. So there's some setup that's normally used for Lisp to actually go in and run, usually bringing up the majority of the runtime behavior and runtime data structures necessarily to execute a Lisp application prior to actually running that entry point. But there's another very similar thing, and we actually saw it before, and that's the Facile File. We've talked about the Facile File in the past when we were talking about ASDF itself and seeing how ASDF 3 generated these files for loading and running and all this kind of stuff, and you can certainly use ASDF to do this. But you have in UIOP this image API that essentially gives you a way of portably dealing with images within a running Lisp image. So you have the ability to check to see, for example, if you dumped an image. So when you dump this image using UIOP/image, you could set this flag so that it will, know that this was a dumped image. So if we look at this right now, and we do UIOP/image star image dumped, you will see that this flag is not set because obviously this is not a dumped running Lisp image. I started this guy from scratch. It has not been set by any sort of runtime. You can actually use this and provide hooks into the running Lisp image when it's getting loaded to not only deal with cases where, like, when it is dumped and we are dealing with the dumped image when we're loaded up, clear out, for example, the configuration directories if we ended up accidentally packaging, files that shouldn't have been there. Things like this. You can also talk about registering hooks for when a Lisp image is loaded. You could run certain code for pre-system checks that are necessarily for the application to run smoothly. This is done with UIOP/image restore hook. Yeah. So you can see already that the image restore hook is a list of different things that are going to be run. These are setting up the user cache when it's loading up, setting up the temporary directory that is necessarily to actually dump temporary files while you're running your application. Command line arguments if you needed it, and of course, because UIOP stream, if you recall when we talked about UIOP stream, standard error doesn't necessarily exist depending upon the Lisp implementation that you're using. Like in the case of SBCL, for example, it provides it as part of the SBSys package, but it isn't actually necessarily, I think, a thing that's inside. And again, I could be wrong here, but I don't remember seeing like star standard error star. I've seen standard output and standard input being earmuffed to variables, but not standard error. But since Unix requires a lot of applications to provide that standard error stream, a lot of Lisp images provided usually through some sort of proprietary extension API that's available in UIOP. Kind of combined all those in UIOP stream. So you need to set these guys up through setup, standard error, standard out, and standard in for your normal things. But in addition to that, if you want a API that or a function call that needs to be run when the Lisp image is loaded, your Lisp application, you can register it in this list, and it will get called through a fun call when the Lisp image is actually loaded if you use UIOP image to actually go and deal with your images when you're loading them up. And you could set this up as part of your build system. Other things that are things, and these are again portable based on different Lisp implementations will do different things that you would want to be aware of. That's in UIOP image. It's related to dealing with command line arguments, dealing with whether or not you should be in Lisp interaction mode. How do you handle fatal conditions for your actual application itself? So register hooks for dealing with that. There are obviously function calls for dealing with creating, dumping, and restoring the image itself. And finally, you have the ability to also print your back traces and stuff when you're actually crashing inside. Or if you end up crashing inside your Lisp application when you're before actually terminating the application itself, and those are print backtrace, print condition backtrace, and so forth. We can look at a couple of these here. Lisp build. Do this. Print. Oh no, not Lisp build image. Print backtrace. As you can see here, these are just hooking into your runtime and the debugger runtime to actually go in to tell you those conditions. Did I mess that up? Oh. No values. Print condition backtrace queries the history of see if I can do this. SB. Oops. Okay. Why did that change? Okay. Interesting. Did I miss the print condition backtrace? Condition type. Unbound. That's a variable. Well, I guess. Oh, right. So print condition backtrace actually prints the condition, and its underlying data after a particular call triggers a backtrace that ends up using that condition itself. So this is normally used for like if you're like debugging different an application you wanted to print out and dump the contents of a particular condition. This function is what you would use to register whenever an error condition occurs. So normally you would probably want to use it in like the case of using what was that thing that I was telling you about, the fatal condition inside the Lisp image. If you end up UIOP image / fatal condition, you could use this print backtrace guy to actually go and register a callback that you can end up using to dump out the condition itself prior to actually exiting the application. You could also use that for handle fatal condition itself. So the last two topics that I was going to be touching base today, and this really covers the pretty much the final two packages that are inside UIOP, are dealing with APIs related to kind of they're APIs related to backwards compatibility um, with earlier incarnations of UIOP, and uh, the driver API, which re-exports all of the above utilities, and that is UIOP itself. So the top level API is driver. If you're looking at the package driver inside of the documentation, it really is behind the scenes, just doing nothing more than exposing to you as a single UIOP package namespace all of the utilities that are available in UIOP. So when you call UIOP : and you're seeing all of these, UIOP : is driven by UIOP/driver. So you'll end up having, if you use UIOP/driver, it's almost the same exact thing. So you don't necessarily need to use this driver API, but I'm only mentioning it because if folks are looking at this and wondering, well, we never covered this library, what is this? That's what that driver API is. It doesn't have any additional functionality. It is literally nothing more than a re-export of all those symbols into this top level namespace. The backward driver API is something that I wanted to at least touch base on, because there are those of you who might have the opportunity or the luxury of actually maintaining or using or extending an existing Lisp application. You may be wondering, how do I get out of this mess of using older versions of these APIs and being able to move forward? Well, the UIOP/backward driver package provides at least some backwards compatibility with earlier incarnations of UIOP. ASDF internals, for example, had a package, a separate package, like ASDF utils, that provided some functionality that this backward driver API has subsumed. Older versions of UIOP have, additional pieces of functionality and functions that may have been subsumed by additional packages that we've mentioned earlier. But given that they may have different signatures, there may have been some, compatibility APIs that need to be written. Those are also inside backward driver 2 as well. And this is also including leaky abstractions that may have been available. I will say available with quotes, in older versions of ASDF, but no longer are available. Those and it's because they shouldn't have been available in the first place. Those internals have also some functionality inside of this UIOP/backward driver package. Just to mention a couple of things, I really don't want to bring up some of these for other than just for your information. These are here. There are things like coerce path name, user configuration directories, and system configuration directories, which have their own equivalents, as we mentioned earlier, for in UIOP/configuration. Things like in first directory, or in user configuration directory, or in system configuration directory, and version compatible P. These are all related to APIs that may have existed but may no longer may no longer needed, or they shouldn't have been even provided in the first place in the case of the leaky abstraction, as I mentioned earlier. This backward driver package, just to fill in all the gaps so that you have a single package that you're essentially using, will end up, and it does, subsume all the other packages. So you could think of this backward driver package essentially being the driver package plus from some additional functionality that may have existed in earlier incarnations, but have either been deprecated or completely removed, and they're only there for a short amount of time. My recommendation for folks who are in these particular situations and looking at these existing systems using these, if at all possible, try to restructure the code so that it will end up using the newer versions of the UIOP library as is, so that eventually some of these can go away. I mean, it may no longer need this package, but for folks who don't have that ability to do so, and you still want to use UIOP and maintain and stay up to date with UIOP, this library or this package is available and is at your disposal for use. And this way you can at the very least be able to use newer features in a newer version of the library and still be able to use the UIOP in a forward-moving manner, and you don't end up sticking yourself up and get stuck in the past just merely because of the fact that you have some functions that require some of this existing functionality. So that's it for UIOP. I hope this provided you guys a decent overview of the library. Again, I didn't cover everything here just because there is a lot of functionality, a lot of functions inside of those APIs, but I did highlight a couple of things that I thought were pretty useful. And so, are there questions? And if not, I'll end it for today. But I'm gonna just stop right now and open the floor for questions or comments. Well, if there are no questions, I appreciate everyone joining me on this Saturday and going through UIOP with me. Tune in next week for more Common Lisp Study Group, and thank you for joining. I'll see you guys next week. See ya.